All right, so with this second example, you probably know that it's a little bit more challenging, if you would, because we don't necessarily get nice, pretty integer values. But still, I'm going to go ahead and walk you guys through this and put you inside the mindset to try to make this a little bit easier to attack, for lack of better words. All right, so if I have to solve this to find the critical values, one of the things that's really jumping out at me to start is the fact that 2 and 2, the A and the B value, are actually the same. So I think for me, it's actually going to be advantageous to use completing the square in this sense, given the values. Now, you could have solved it using the quadratic formula also, and we'd end up getting the same answers. But in this case, I'm going to use the completing the square, and also realize that I know it doesn't factor because I see 2 and -3, which is -6. No factors in -6 give me 2. All right, so if I'm going to go ahead and complete the square here with this, this is then going to go ahead and I've got to get A equal to 1, so that would give me x squared plus x minus 3. And again, I'm just making this an equals 0 scenario. And then realize, like my scratch work in completing the square, b equals 1. I got half of b, which is 1/2, and then half of b squared, which equals a 4th. So what I'm going to actually add inside here is plus 1/4. Now, where I have to be careful is I have to realize to keep this balanced, I have to be able to, since I added this, I got to subtract the same value, but that's 2 times 1/4, which is 1/2, like so. So now my next line would actually be 2, and again, this is where my scratch work pays dividends, x plus 1/2 squared minus, this would actually be 6 over 2, so we're going to say 7 over 2 equals 0. All right, so now inverse operations, I have x plus 1/2 squared equals 7/2 times 1/2, because I divided both sides by 2 or multiplied by 1/2. So this is actually going to be 7/4, which is actually nice, believe it or not, because I get x plus 1/2 equals plus or minus square root of 7 over 2, or x equals -1 plus or minus square root of 7 over 2. And I wrote it like this just because if you use the quadratic formula, that's probably what your answer looks like. But it is possibly even advantageous for us to think about it in the form of -1/2 plus or minus square root of 7 over 2. And here's the reason why. Our next step is we have to actually think about like our critical values for our table. So we have this -1/2, and we have minus square root of 7 over 2. And I got 1/2 plus square root of 7 over 2. So now what I have to think about is, what is the square root of 7 over 2 actually equal to? So if I'm thinking about that, well, square root of 7, if I just approximate, well, I know 2 squared is 4 and 3 squared is 9. So this is, let's just say, approximately 2.4. Some value, right? As long as I know it's between 2 and 3, we're in good shape. Because now here's how that plays dividends for us. I see 2.4-ish. Well, it's basically 2 over 2, so that's going to be approximately 1. So this value here is approximately 1. So if I go -1/2 minus 1, that'd be -1 and 1/2. So whenever I go and set up my table, I can actually pick another value out here, and let's just say -3 is a value that we select. And then to the same respect, if this is going to be, this should be -1/2 plus 1, this value here is actually greater than this, so this is important because this will be a positive number. That will give me the ability to put a 0 in. And I love whenever I can put zeros as test points. And again, if I'm approximating this value, it looks to be roughly around 1, so let's just go ahead and put another value just to make sure we're safe. Let's put the value 3 outside there. All right, so now you can see when you're setting up your table of values, when you get radical values, it can be a little bit challenging at times, but just by estimating, I also tried to go through the estimation skills because this would be a non-calculator type of question. All right, so realize, yes, I could type this into a calculator to get the values, but the mindset would be that we could also do this without a calculator. Now, one of the things I love seeing that 0. So if I go back up here, I get -3 less than or equal to 0. Well, that is true. So this is going to be a true statement here. That's big. All right, let's go ahead and substitute -3 in. So now, if I'm looking at -3, so this would be 2 times -3 squared plus 2 times -3. Boy, a lot of 3's there, right? This is going to be 18. So 2 times 9, which is going to be 18, minus 6 minus 3. Well, either way, all we're really worried about is it positive or negative? 18 minus 9 is actually going to be a positive number. So -3 is false. So this is actually going to be false. And then, since I'm going to put a positive in, well, basically, that changes, and this changes. And if I put a positive in, well, the 18 still stays positive. Oops, let's just try to erase that a little more. But now this becomes a positive 6, which either way we see that this is going to result in a positive number, which is obviously bigger than 0. So this is actually going to be false. So then the question becomes, what's our solution set? Well, we're not going to infinities. We're staying bounded right here. So that's going to mean that our solution set, given that it's a less than or equal to symbol, is actually going to look like the following. We're going to have -1/2 minus square root of 7 over 2, bracket to -1/2 plus square root of 7 over 2. Now, again, this is probably the most involved style of question that we're going to have. But what I want you to look at here, and this is something that you're going to see a trend with, is the fact that we're either going to have the outsides be false and our inside be true, or we'll have our outside be true and our inside be false. That's always going to take place. I should say always. 95% of the time will take place. So now, before you go on to the graphing strategy, I want you to think, well, why is that true? And then maybe even a better question is, when might it not be true? You'll get those answers in videos to come here in a little bit.